Hey, welcome to Unknowns. Today, we are going to see how to make a phylogenetic tree more elegant. Okay, for example, here we have a Trichoderma viride tree, but to support the species identification, this is completely insufficient. Rather, you take a look on this tree. We have Trichoderma viride branch here. The unknown sequence clearly branch inside the viride branch, and other species of Trichoderma are placed in the adjacent branches. So the tree's length is also very elegant, and by looking into the tree, you can clearly say it is Trichoderma viride. So let's see why this tree first. What we have done here. So usually we will go for blast analysis. Here you have given a sequence, and this is how the default selection will be. You are going for blast analysis, and this is the result where you see the first maximum percentage of identity is 98.74, but all are Trichoderma viride. So I would recommend you need to collect variable sequences to make the tree look elegant. Okay, so how to collect that? Instead of selecting standard database, select rRNA ITS database. After selecting, you will have this pop-up. Select internal transcript spacer because that's what we are blasting. Let's blast against this specific database. So when I click blast here, and this is how the results looks. If you see, now we have, there is no repeated species. We have various species from which you can take the sequences. So what I do, I scroll down to the bottom. I will start selecting sequences from the bottom because that's where the lowest percentage of similarity is there. So I select this. I select sequences in equidistance manner so that I tend to sample all the variations, okay, towards my target sequences. So in equidistance manner, I select the sequences. All right, and I will download these sequences. See, here when I use the standard database, the maximum percentage of similarity is not even 99%. It is 98.74. So when I use a special database, I will never select any sequence that is equivalent to 98% similarity or more. I will always select sequences which is below 98%. This way, I can avoid the confusion in the tree. Okay, this is very much important that we select sequences of variable percentages and similarities so that, and another specialty of this specialized databases, you will have all species of Trichoderma here. There is no repeated species like that of standard database where only Trichoderma sequences are repeated completely. But here you can see in numerous number of species in Trichoderma whose ITS sequence you can directly access here. So after collecting, I have prepared a file, a notepad file. You know how to prepare this FASTA format. So I have prepared it, and I have included my target sequences for drawing the phylogenetic tree. So that's how this file, both standard sequences. From the standards, I need to mention that from the standard, I selected only 4 sequences. Okay, approximately around 98.56, all Trichoderma 4 sequences. From the specific database, I selected around 11 sequences. So 4 plus 11 is 15, and my sequence is 16. So 16 sequence tree I have constructed here. So that's how this tree was obtained. So after making this FASTA file, I have went to the blast. In the mega, I have pasted the sequences. I have aligned it. Any gaps inside the sequences was actually trimmed off. Then finally, I went to a phylogenetic analysis. No, it is not a protein coding gene. It is a ITS and 6NS rRNA gene are not protein coding gene. There is another node. So this is already loaded. So I will go for phylogenetic tree construction where, okay. So all default parameters. Now I got the phylogenetic tree. Okay. So initially tree may look like this. Remember, you can increase the tree width. When you increase it, you can see the resolution here. So that's how the tree is obtained. Um, so I'll go here. I need to mark my sequence, compress, expand. I will introduce this symbol so that anyone who sees the tree can recognize the sequence I produced in this study like this. So now you know, image, save, you will save the tree. Okay, whenever you are giving your results for customer, this is also important. Better you copy the caption and have it in a separate file. Caption, copy to the clipboard. You can open your file, and since it is copied, Control V, you got the caption here. Okay. So disclaimer can be deleted, and this should be emailed for the customer. That's how we make phylogenetic tree in barcode biotechnology.